Namaste and welcome back to the DSA classes. Today we are going to be discussing another question from LeetCode, question number 33, and this question is called as search in rotated sorted array. And this question, my friends, has been asked in your big fan companies such as Google and Amazon as well, right? So what is this question all about? Let's go to LeetCode and just read the question. So the question states something like this, right? There is an integer array nums sorted in ascending order with distinct values. Okay. Prior to being passed to your function, nums is possibly rotated at an unknown pivot index k. Okay. Now, for example, 0, 1, 2, 3, 4, 5, 6, 7 might be rotated at index 3. Index 3 means 0th index, first index, second index, third index. So see, at this index they will rotate. If they rotate it, then 4 will come here, 5 will follow, 6 will follow, 7 will follow, then 0, 1, 2 will come after that. So see, 4, 5, 6, 7, 0, 1, 2. So it was a sorted array with distinct values. But before sending it to your function, they will rotate it at a given index called as pivot, and that is what you will have. And in this rotated sorted array, you have to perform search. Then they will give you a target value. They will give you a target value. Now what you have to do is you have to search. For example, target is 0. So 0 is there at the 4th index. So 4 you should return like that. Any confusion till here? And it's a medium level question. But if you guys have been attending the DSA classes here at App Academy and you've understood binary search the way I have taught it to you, this becomes an extremely easy problem because see here, you must write an algorithm with log-n runtime complexity and you have to do search. So search, log-n, sorted array. These three keywords is what should trigger your brain to think in terms of binary search, right? Now what do I mean by this? Let me show you. Now watch it, friends. What they are trying to say is, originally there will be an array like this. So 1, 2, 4, 5, 6, 7, 8. But before passing to your function, they will rotate it. Let us assume they will rotate it at index 2. If they rotate it at index 2, then 4 will come here. That is what I am showing. Then 5 will come here, that is what I am showing. Then 6 will come here, that's what I am showing. Then 7 will come here, that's what I am showing. Then 8 will come here, that's what I am showing. And then the rest of the numbers will come after that. So it will become 4, 5, 6, 7, 8, 1, 2. Then they will give you a target value. Let us assume target is 6. So in this rotated array, 6 is at second index and that must be the output that your function returns. Now, how would one go about solving this? I would say pause this video and try to come up with a solution on your own. Assuming you have done that, I am moving forward. So watch this, guys. This is how I would come up with a solution. So listen to me. This is the array that has been given to me. Initially it was sorted. Then what happened is they rotated it and they gave it to me. This is the array that I have. Okay. And right now they'll also give me a target value. I'm not giving any target value. Let us assume it's empty for the time being. Okay. Now let's come up with an algorithm. Okay. Now if search has to be done on an array in log-n complexity, the only way you can do it is by making use of binary search. So if binary search has to be used, then you know initially low will be at the 0th index, high will be at the last index, and you will calculate mid, and mid will be somewhere here, right? So I'm just writing the loop, outer loop of binary search, which is nothing but while low is less than equal to high. Now inside that I'm calculating mid. Mid is equal to low plus high divided by 2, and if you do 0 plus 6 divided by 2, mid will be 3. Now here listen to me carefully. First thing obviously in binary search is you will check if the target is the middle value, right? Let us assume the target is 5, my friends. I am making the target as 5. Let us assume it is 5. Now I will check if in case target is equal to the middle value. Obviously target is not equal to the middle value, but if it was equal, I will return the mid index and that is the position of my element, right? But obviously that is not the case. Now this is where the complexity comes. That's why Google and Amazon are asking this. If you look at this array, this is your mid, right? If you look, the array can be split here. I mean, forget about splitting. If you look at this array, you will see it is sorted to the left also. It is sorted to the right also. And if you look even more closely, you will see here also it is in the ascending order that sort is happening. Here also it is in the ascending order that the sorting is happening, right? So if one side was ascending, another side was descending, maybe you could have borrowed some knowledge from that bitonic array approach and you could have applied it here, but you cannot apply that here because this side also sorted, this side also sorted, ascending and ascending, which means there is no way for you to check whether the element will lie on this side or the element will lie on this side. It may lie on this side also, it may lie on this side also, which means you will have to check to the left sorted array, you have to check on the right sorted array also. Now, how are we going to do that? Very simple. What I will do is, first of all, I would like to start searching in the left sorted array. I would like to start searching in the left sorted array. Now, how will I take my search to the left sorted array if you ask me? Simple. Look at this, guys. Look at where low is. Low, wherever it is, it doesn't matter. Look at low. Right now it is at 0th index. What is the element at the 0th index? 4, right? If you notice, 4 is less than your middle element. 4 is less than your middle element. If wherever L is less than your middle element, would you say or can you conclude you are in the left sorted array? Because if you are in the right sorted array side, then tell me, if I check whether low is less than the value that middle is pointing to, if let us assume middle was here, will it be lesser? No. Then obviously you know you are not in the left sorted array. So the easiest way to check whether right now are you in the left sorted array or whether you are in the right sorted array is to check whether the low value is less than or equal to the mid value. What do you mean, you may ask? Let us assume low is here, mid is here, okay? 4 is less than 7, 5 is less than 7, 6 is less than 7, 7 is equal to 7. Which means if low is less than or equal to mid, you can conclude you are on the left sorted array. Would you agree with me? So watch carefully. If at all the target is not equal to the middle value, I will tell else and I will put a condition. If in case in my array the element at low, if it is less than or equal to the element at mid, less than or equal to the element at mid, right? Then what is going to happen if you ask me? Now I will come inside. Now I know I am in the left sorted array. Now I want to check whether my target, which right now is 5, is it there in this range? Is it there in the left sorted array? That is what I want to check. Now how will you check? Very simple. If really the target was there in this range, would you agree it will either be greater than or equal to the low element? See, equal to, greater than, or it will be lesser than this mid element. Sir, why not less than equal to? Why? Because whether it is equal to the mid element, you have already checked. Because this condition failed, only you came here. So obviously you know it is not equal to, but I want to check in this range. See, I want to check in this range. How will you check in this range? Equal to low or greater than low, less than mid. Would you agree? So what I will do is, I will check whether it lies in this range. So I will put a condition. Inside that if, I am putting another if condition. If in case the target element is greater than or equal to low and the target element is less than mid, then I know, boss, my search must be restricted from here to here. If my search must be restricted from here to here, should I move low or should I move high? Use common sense and tell me, what will you move? High. Where will you move high to? Mid -1, which means, would you agree that this high value should be brought here? That is what I am also doing. I am telling, if both these conditions are true, then please make high as mid -1. But let us assume that condition was not true, boss. The condition was not true. If it is not true, then I know it is not in this range. If it is not in this range and it is not equal to this, it should be this side. If it should be this side, should I adjust low or should I adjust high? Naturally, you have to adjust low. So low should become mid +1. So see, else low should be equal to mid +1. So what did I do so far? I just applied binary search, checked if my target is a middle element. If not, I checked right now, am I in the left sorted array or am I in the right sorted array? If I am in the left sorted array, for that I have written the condition is low less than equal to mid. If I am the left sorted array, then I check whether my target value lies between low till here. I checked. For that I wrote a condition. If that is the case, I know I should search only here. I brought high as mid minus 1. If not, I know it is not here, so I have to bring it here. So I made low as mid plus 1. That's it. Simple. Simple. Now, this was to check if you are in the left sorted array and whether your element rise within the range of values within the left sorted array. But if you are not even in the left sorted array, if this condition was false, then I will come to else. I'll come to else. Any confusion till here? In else, if I come to else, what does it mean? I am in the right sorted array. I am in the right sorted array. Now, else means what, guys? Else means you are not in the left sorted portion of the array. You are not in the left sorted portion of the array. That is what it means. If this condition doesn't satisfy and you come to else, that's what it means. Now, it means what? You are in the portion of the array which is the right sorted portion. Now, what does that mean? See guys, don't think that this is the kind of array you can get. They can rotate the array at any point. Let us assume they rotated the array differently and sent it to you like this. This is also same array, rotated differently. How are you able to think? Now, this is low, this is high. If I calculate mid, same index only. But look, where are you? Mid. Are you in the left sorted portion or are you in the right sorted portion? You are in the right sorted portion. If you come to the right sorted portion is when you come to this else part. Now, if you are in the left sorted portion, you checked if in case the element lies in that range of values or not. Now you are in the right sorted portion. Now, don't you think you must check whether the elements lie in this range or not? For that, how will you write the condition? Simple. If in case the target value is greater than my mid value. It was not equal to, that you checked. So obviously, if you are in the right sorted portion, it has to be greater. So greater than the mid value. So see, target is greater than A of mid. And don't you think it should be less than or equal to the high value? And target is less than or equal to the high value, then I know it lies in this range. How are you able to think? If I know it lies in this range, next time when I loop, I want binary search to be restricted only in this side of my array. So tell me, will you adjust low or will you adjust high? Naturally, low should become mid plus 1. That is what I am telling. Else means what? It did not lie in this range. If it did not lie in this range, it will lie on that side only. If it should lie on that side, will you adjust low or high? High should come mid minus 1. Now we are able to think. As simple as that. Even now it is binary search only. Modified to suit your needs. Now we are able to think. So again I repeat. What have you done? What you did is, you applied binary search. You got the mid element. You checked if the target is equal to the mid element, then wonderful, return the mid index. You found the element, its position. If it was not the target element, then you checked whether the middle value is on the left sorted portion or right sorted portion. To check for left sorted portion, you checked whether the target is greater than equal to low and less than the mid value. Then you know that it will lie in this range. Then accordingly you adjusted high. Otherwise you adjusted low. Similarly, when you find mid and if it lies in the right sorted portion, you checked whether your target lies in this portion, which is mid plus 1 to high, this range. How are you able to think? If it lies in this range, then you adjusted low here so that it comes here. If it doesn't lie in this range, it has to be in this side, so you adjusted high. That's it. Google question, Amazon question. I hope everybody understood how to approach this problem. Now, if it is binary search, complexity is log n, so you have satisfied that as well. So shall we go and check whether this logic actually works? What are we waiting for? Let's go write some code. Let's write some code. I've created a function called a search which returns an integer because index accepts an array as input and the target element to search for. Because we are using binary search, low has been initialized to 0, high to the last index, mid is initially 0, which means I have low here, high here. Now I will go write the loop. So I'll tell as long as L is less than equal to H, I'll first calculate mid. So mid is going to be L plus H divided by 2, and if in case I do that, this is going to be mid. Okay. Now then I will check if in case my target element, let us assume my target element in this case is 5. Okay. Let us assume it's 5. I will check if the target element is the mid element. And then if so, I will just return the index of mid because that is my position. Great. Else, if in case. Okay. Now why did I write if? Because now I know it is not the middle element. Now I want to know whether this mid element is in the left sorted portion or in the right sorted portion. If it is in the left sorted portion, then this element where low is will definitely be less than or equal to mid. That is the condition I just taught you. See, less than mid, less than mid, less than mid. If it was here, equal to mid. So I'll check if in case the element at low, A of L, is less than equal to A of mid. If this condition satisfies, then I know 100% I am in the left sorted portion. Now in the left sorted portion, I want to see whether my target lies. So what will I do? Like this. I will just go there and I will check if in case it lies in this range. So how will I check? That is if in case target is greater than or equal to A of low. Okay. And target is less than the middle value. If so, 100% I know that it lies in this range. Now that I know it lies in this range, what I will do is I will adjust my high and bring it here. So I will tell H is equal to M minus 1. If not, else. If not, I know it doesn't lie in this range. First only I checked if this is the value. No, then it has to be this side only. So low is equal to mid plus 1. That's about it, guys. Next, I'll come and I'll tell else. Now, else means what? Else means that you are not in the left sorted portion. You are actually in the right sorted portion. Let us assume the array was like this. Obviously, this is L, this is H, this is M. You checked if M is the value. No. Then you checked if low value is less than or equal to M. No. No means obviously you are not in the left sorted portion. You are in the right sorted portion. Now you are in the right sorted portion. Great. Now what you want to do is, you know this is not your element, but you want to check to the right side. You want to check whether it lies in this range or not. If it lies in this range, it should be less than this value, less than or equal to the high value, and it should be greater than the mid value. Would you agree? That is the condition I am putting. So if in case my target is greater than my middle value, and is less than or equal to my high value, A of H. If that is the case, I know my target lies in this range. So obviously my search should be restricted only here. So low comes mid plus 1. If it did not lie here in this range, I know it will not be here. I know this is not the element because first only I checked. It has to be this side. So high becomes mid minus 1. That's about it, my dear friends. Any confusion? If I come out of my while loop and never my target, if my target was never equal to the middle value, then I know that element was not there at all. So I'll come outside and return -1. That's about it, right? Great. Okay. So now let's just quickly go and check whether this is there or not. So watch it. So I'll come down and okay, let's just paste it in LeetCode itself. Why? Simply because let them pass the test cases. Okay, copy, and I'll go take you to LeetCode, and there I will just first increase this. I'll paste it. If in case I paste it, then what I will do is I'll go on top. There it's nums, guys. We have used A everywhere. So what we will do is we will in the signature itself change nums to A. That's easy. Otherwise, everywhere, wherever A is, you should go make it nums. It doesn't matter. So these things are allowed. Okay. Now, if in case I go and run the code, then let's see whether there is any issue. Accepted. If I submit it, then pull this. Definitely. So runtime is around 1 millisecond faster than 32.78% of online submissions is what it is telling. Okay. So definitely it works. Any confusion till this point of time? So I really hope you enjoyed this problem. Make sure you guys also go and are attempting the solution on LeetCode. Other than that, make sure all of you are practicing, because by watching me code, you will never become a coder. The more you code, the more closer you get to your dream. Any confusion till here? Great friends, thank you so much for tuning in. Let's catch up in the next class with even more amazing programs. Till then, take care. Bye-bye.